So kindly confirm, am I audible? Shall we start the session?
Yes, you are
Yes,
audible. Please start.
yes, good evening, sir. You
Good
are
evening.
completely audible.
So, sir, shall we start the session now?
Sir, within 1 or 2 minutes, let's see,
Okay,
could be another student, another participants could join.
right.
And good evening, the expert of today's talk, Dr. Amit Doegar, and dear participants. So on the behalf of Guru Nanak Dev Engineering College, along with my colleague Dr. Sandeep Kumar Singla, welcome you all in the today's talk. So Dr. Amit Doegar, who is the next resource person for the expert talk, I want to share briefing of his profile. He had received the bachelor degree in computer science engineering with the distinction from Karnataka University, Dharwad in 1998 and Master of Engineering in Computer Science and Engineering from Punjab University, Chandigarh in 2008. He has completed his PhD in the area of image forensics from Punjab University, Chandigarh. He has been working as associate professor in the Department of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, Chandigarh, since February 2001. So currently he is handling the additional duty of head of department as well. And I believe many of the participants may have visited NITTTR Chandigarh for attending the short-term courses which are routinely being organized by this HRD Ministry Institute. So before joining the NITTTR, Dr. Doegar has worked with the software industry at Bangalore. He has, to his credit, more than 60 publications in international journal and conferences of repute. His research interests include machine learning, image processing, data analytics, and open source technology. He has guided more than 70 master students for research in different areas of computer science and engineering. He is a life member of Computer Society of India and Indian Society for Technical Education. So, Dr. Amit, we are very thankful that you are sparing the time for the talk. The proposed talk is the cyber analytics insights and trends in cybersecurity analysis. Now, sir, you can start the session, please.
Okay, thank you, sir. Thank you so much. So kindly confirm me, am I audible and screen is visible?
Yes, sir, the screen is visible and you are completely audible. Thank
Okay,
you.
thank you, one and all. So thank you for giving me the opportunity for this FDP. So first we'll talk on what is cyber analytics. So any participant would like to comment? What is cyber analytics? What do you understand by cyber analytics? Anyone? Either they can unmute or they can write on the chat box. Okay, let me explain. And I can see the chat messages. If in case in between, if any participant has any doubt, question, query, they can ask in between. So when we talk on the cyber analytics, it involves the analyzing the data, collection of the data, processing of the data from various digital systems for what purpose? To detect any kind of attacks, to mitigate the threats and improve the cyber security, or detect the anomalies in the, that is a cyber analytics. So cyber analytics involves a lot of data, and so why it is important for us to protect against cyber threat like data breaches, intrusion attacks, malware, distributed denial of attacks. So very rightly, like Dr. Supri has mentioned, analysis of network packets. So we have various tools through which we are going to analyze the network packets. So after this presentation, parallelly I will demonstrate you also. So to protect, proactively secure the system by predicting potential vulnerability. So how to do the prediction? So we have to use some kind of statistical techniques, machine learning techniques. So what are the key components involved in this cyber analytics? So first we need to collect the data. So there are various open source and proprietary tools are available through which Wireshark is one of the tool. So I recommend if you are teaching some network uh, related topic, so in that you can explore all the layers, application layer, transport layer. Practically you can show the packets to the students using the Wireshark. So you can gather the data from logs, network traffic, what are the user activities are there, what are the endpoints are available. After the collection of data, we need to do analysis using certain statistical and machine learning techniques to identify the patterns. For example, cluster the IP address to detect the usual and unusual activity. Then also we can visualize, we can presenting the insights through dashboard and reports. And finally, we can make the decision and we can automate the response like isolating the infected devices or flagging the suspicious activities. So today's agenda, and to demonstrate, I will show you how to detect the DDoS attacks using machine learning techniques. And in section 2, detect the intrusion detection system. So now what is distributed denial of attack? So this is attempt to make a network resource unavailable by giving a lot of traffic to the particular resource. And we, in this kind of attack, we can have the now role of machine learning. So using the concept of machine learning, we can identify the patterns, what are the patterns are there in the network traffic, and we can automate the direction of malicious activity. So now for this, I'm going to use this data set, and on the given link, so on the chat box, I'm writing one log. And parallelly also I'm showing in the screen fastcommunity.wordpress.com. So once you go here, fastcommunity.wordpress.com, there is a link is available. All of you can join to this Google Classroom, and I'm also pasting this link in the chat box. So code, entire data set, and presentations, all of you can download. So here, so if we are going to use the network traffic data set, I will explain each and every point of this. Then there are certain attributes and targets are there, like what is the source IP, what is the destination IP, what is the traffic volume, etc. What we have the consist of features, and we have the target variable normal, or is it a type of attack. Now after reading this kind of file, we need to do some kind of pre-processing. So first we need to find, is there any missing values are there? In case if there is any missing value, we need to we have to handle the missing values. So in this data set, you may get two type of features. Either it will be numerical feature or non-numerical, or also known as categorical features. So using the categorical feature or using the numerical feature, we need further pre-processing. So for various machine learning, data has to be in the numerical format. So we can encode the categorical feature using the label encoder, and numerical feature we can do the standardization. So for that we can use the standard scaler. So example, like for example, uh, what there may be various columns could be there. So there is a inbuilt command in Linux, that is a part of this. We can call this label encoder, and we can just fit the transform and transform all the columns which are in the form of categorical to the label encoder. So for example, if I have, let's say, three categories are there. Let's say the A, B, C are my column names, and under this I have multiple. Let's say I have. Let's say this is my protocol TCP, UDP, ICMP, and the repetition of this. Or maybe I have maybe a IP, a source IP address, and here I have the destination. So this is the source IP address, and this is the destination IP address. So let's say it is repeating T, U, I, then again T, U, I. So when we convert into label encoding, it will get automatically some numbers to this. 1 to T, U to be UDP protocol number 2, ICMP as number 3, again TCPI as number 1. So wherever there is a UDP, number will be there. So that is the meaning of the label encoding. Apart from this, we have also the techniques, but this is a simple way. Then we do the data splitting. We have the training and testing splitting. So training is meant to train the model. So training is used to train the model, and testing is used to see the performance matrices. So training data is used to train the model. Now we need to train the model. So there is a function fit. So to train the model, we use the training data, and to see the evaluation, what is the performance matrices, we use the test data for to see the performance. So in performance, we have various matrices are there like accuracy, precision, recall, F score, etc. So how we got this? So test data is to evaluate the performance. Now how we got this? So there is a concept of confusion matrix. Because in practically also I will show you. So let's say we have the ground truth and we have the predictions. So now in the ground truth, we have the data. So the data could be normal or it could be attack. So it could be a normal data or it could be an attack. So how to identify this? There are based on the signatures of the kind of the pattern we can identify. So either it could be normal or it could be attack. So we can mention here as a true or positive or negative. So positive means it's a normal data, and negative means it is a kind of attack. So again, we can have here positive prediction on negative. So now what is the prediction is here? Positive. Prediction is positive here in this flow, and here prediction is negative and negative. Now we can relate this with the our ground truth. So ground truth is positive and this is also positive, so it is the true positive. So now ground truth is that data is positive, that is normal, but our machine is saying it is a type of attack. So this is known as false negative. Again, there is an attack. and our machine is saying no, it's a normal. So again, it's a false positive. And there is an attack, and our machine is also showing it's a negative or a kind of pattern or attack. So it is a true negative. So our main purpose is to reduce the false positive and false negative. Our main purpose is to reduce the false positive and false negative. These are also known as type 1 error and type 2 error. So now what are the, how we can find out this? So accuracy is true positive. You can take the snap, otherwise if you are aware, then you can, or you can note down true positive plus true negative divided by all tuples. All tuple means true positive plus false negative plus false positive plus true negative. And what is precision? So precision I am writing as PR. So precision is the positive prediction by the machine divided by total prediction by the machine. So total prediction is true positive plus false positive. So this is the one performance matrices: accuracy, then we have the precision, and then we have the recall. So here I am writing recall. So recall is the prediction by the machine, true positive, divided by the total ground truth. So total ground truth is true positive plus false negative. I hope this is clear to all of you. Then we take the harmonic mean of precision and recall, that is known as F1 score. F1 score. So how to find the harmonic mean? So the number of tuples. So how many tuples are there? 2 divided by 1 upon precision plus 1 upon recall. If mathematically we further simplify it, the equation will become on the here on this side I am writing now on this side. So you will see it will be 2 divided by R plus P divided by the LCM. We can take P into R. If further we simplify, the final equation will be 2 into P into R divided by P plus R. So kindly note down this, because I will show you some confusion matrix, and I may ask you what will be the accuracy, what will be the precision, what will be the recall. And in Python there are inbuilt classification report is that automatically it will come, but it depends on the confusion matrix. I hope to some extent it is clear to all of you. So shall I clean now? Shall I clean this? Okay, thank you. So now there is a inbuilt function train test split, and here we pass these parameters. Now what are these parameters? X stand for the features. Now in any equation like here, so let's say there is a equation y is equal to mx plus c, simple equation of a line where m is a slope and c is the intercept. So here you can see this is a dependent variable and this is the independent variable. So this is known as features. So this is known as features, and this is the target, and this is the target. So target is a dependent variable and x is an independent variable. So when we are passing here x and y, so we are passing the features. We are passing the features, only the features. We are passing the features. Then we are passing the target. Then we are specifying the test size. If we don't specify the test size, so it will take 75% for training. These are known as holdout splitting. 75% will go to the training and 25% will go to the testing percent. But here we have specified 0.2. That means 20% we are giving to the testing data and 80% we are giving to the training data. So there is even k-fold approach is also available. So this is a simple holdout. So here we are using 80% data to the training and 20% to the test data. And we are giving the random state. Why we are giving the random state? It is just like a seed value. Because again, after if you don't specify this random state, again if you run the after splitting and after you will get some result, again if you run the code you will get different result, because randomly it will split the data set into X train and X test, Y train and Y test. To avoid that we are using some seed value, otherwise randomly it will split your data and you will again get these different accuracies. So in this way we specify the train test split, then we use the various algorithm. So I will show you KNN, SVM, decision tree, ANN, neural networks, some boosting algorithms, XGBoost, AdaBoost, some advanced algorithms, random forest. Why we are using multiple algorithms? To compare the performance and choose the best. That is our objective. Because machine learning algorithms totally dependent on the amount of data and the type of data. So if let's say random forest is giving very good result on type of problem, so it is not necessarily, it may also work good with the B type of data. So next, now how to specify the random. So in the one variable, you will call this random forest classifier. You can give the number of estimators, the number of decision taking and model fit. So here you have seen, so this is our training data, X train and Y train, and this is our testing data, X test and Y test. So we need to pass. So these are the labels and these are the features, X train and Y train. So we have to pass here X train and Y train. With this model will be ready. And then we do the prediction using the test data. So this is our test data. Here we don't specify the Y test. So when we specify here X test, we got some kind of predictions. We compare those predictions with the and we got the some kind of predictions here. So for example, again here, let's say this is the ground truth and this is the prediction one by the method. This is a ground truth. So ground truth is 1 1 0 0 1 0 and prediction is 1 0 1 0 1 0. So when it is a 1 and 1, so it is a correct, it is not a misclassification, but here it is 1, it is 0, it is a misclassification. Here it is 0, it is 1, again it is a misclassification. Here 0, again 0, it is again correct 1. 1 1 is again correct 1. Again 0 0 is correct 1. So easily you can now draw the confusion matrix. There you can define 1 0 and this is a prediction here 1 0. So you can see how many 1 1 are there, 1 2. So there are two tuples which have 1 1. Then you can compare 1 0. So how many 1 zeros are there? 1, only 1 is there. Then you compare 0 1. So 0 1 is 1, only 1 is there, and 0 0 1 2. So now this is the confusion matrix. So now can anyone calculate the accuracy? So accuracy will be 2 plus 2, 4, divided by all the tuple values. Accuracy will be 4 by 6. What about precision? So precision will be 2 divided by total prediction. So total prediction is 2 plus 1, 3. What will be the recall? So prediction divided by ground truth. So 2 plus 1 in this direction. So it will be 2 plus 1, again 2 by 3. And what about the uh, F score? So that will the harmonic mean of precision and recall. So that will be 2 into precision is now 2 upon 3. Again, recall is 2 upon 3. 2 divided by 3 divided by 2 by 3 plus 2 by 3. Precision plus recall. So in this way, we got the accuracy, precision, recall, and F score from the confusion matrix in all the machine learning algorithms. So I hope now you got the idea how to calculate these matrices and why multiple models are there. So to compare the performance and choose the best, we use a multiple columns. So this is example of the random forest. Then we compare the algorithms, and we can also do the graphical representation. And also we are going to now predict the KNN. So there the value of K is very important. So that also we will see. And finally, we will do the unassembling method in section 1 or in part 1. So why we are using the unassembled methods? So we can combine the strength of multiple models. So let's say we have implemented here. Let's say here we have implemented 10 algorithms. And out of 10 algorithms, we will see the top 3. So out of 10, we will select the top 3 algorithms which are giving good accuracy. On those 3, we can perform the unassemble method with hard voting and soft voting. Now, what is the difference between hard voting and soft voting? So let's say out of 3, 2 are saying true and 1 is saying false. So we go with the majority of the voting. So our final output will be the true. And in soft voting, instead of giving the direct answer, they are giving in the terms of probability. So if I ask you what is the probability it may rain today, so let's say 3 participants are giving yes, 2 are saying yes, and 1 is saying no. So we will take the majority voting and we will say yes, today it will rain. Again, if I ask you in terms of soft voting, so instead of saying yes or no, some may say there is 90% chances are there, some may say 80% chances are there, someone may say 85% chances are there. Then we take the average of these. So here we consider the probability. So using this, we can combine the strength of multiple models. So these are the performance matrices we are going to evaluate: accuracy, confusion matrix, classification report, precision recall, and F1 score. So machine learning models can effectively detect the, first we'll implement the denial of service attack. And in section 2, we'll do the intrusion detection system. Now, before explaining the section 2, I will demonstrate the section 1. So now, this is the section 1, and here, this is the data set. So kindly confirm me once, is it visible or shall I zoom it? Anyone?
Sir, it's visible.
Okay, thank you. So now I have given the 100. So you can see here we have the duration. Here we have the protocol, whether it's TCP, UDP, ICMP, or what type of protocols are there. And we have approximately in this network traffic, we have captured 2001, around 2000 tuples are there. Then you can see the source IP, destination IP, source port, destination port, packet count, byte count, and based on this, it is labeled whether it's attack or normal, attack or normal. So now I'm going to use a Google Colab, which is very easy to work. So to suppress the warning, sometime it gives the particular model is a particular library is going to depreciate in future. So just we want to suppress the warning. This is optional one. Suppress all one. This is an optional one, not compulsory to suppress the warnings. So this is a optional. This is a optional. Now we, as I have shown you the data set. So this data set contains synthetic network traffic data generated to mimic the real world scenario. So this is designed to aid the development, train and evaluate the IDS and DDS kind of attacks. So this is a DDoS attack. So here DDoS attack and other cybersecurity models attacks. So this data set include the these are the features. So duration, the duration of the network connection in seconds. The protocols, there are three type of protocols are there: TCP, UDP, and ISMP. Source IP, destination IP, source port, destination port, number of packets in the connection, and then byte count and the number of bytes transferred. So here, and the labeling. Now, how this labeling has happened? So this data set is ideal for researchers, practitioners in the field of cybersecurity to develop and to test the DDoS and IDS attacks, and it can be used for classification on network whether it's normal or attack. So this is done by the feature engineering and selection of improving IDS improvement. So it is a supervised based training because we have the labels, we have the feature analysis, and now we are going to read this image. So we have the utility from google.colab. We can import the file, we can run it, and we can upload here. So once you download the dataset, you will find there are two folders, section 1 and section 2. So in section 1, you will find this dataset, network underscore traffic dot data dot csv. So how this data is generated? So various tools are available, as I told you, using Wireshark, TCP dump, or NetFlow are used to capture the network protocol. And these are the features are available. And how labeling is done? So labeling is done by comparing the traffic patterns against the known attack signatures. So like intrusion detection systems are available in open source, like Snort, Shurikata, many tools are available, or anomaly detection systems. So whatever the traffic is coming, we compare their signatures, attack signature. Based on that, it has been labeled as either normal or attack. So that indicates if the traffic is benign or malicious. So one can even simulate the attack like tool like Metasploit, low orbit ion cannon, or custom scripts can be used to control the attacks in the sandbox environment or in the virtualization environment, or like in this way. So now we have read this image. So now this has been uploaded. So now if you see the this operating system used by the Google to give us the this collab. So they are using the Ubuntu 22.04.3 version. So this is a Linux-based operating system. There are around 400 distributions are there. Like Android is one of the variant, Fedora, Scientific Linux, Red Hat Linux, Debian Linux, and this is one of the Linux. So they are behind the scene. There is a Linux. So that means any command you can run here. So if you run here, you have to put the exclamation sign, that is a magic symbol, then ls. So you can see certain data is available here in this platform. Now we have uploaded network traffic data, so it is available here, network traffic underscore data dot csv. Then we import the pandas and numpy file to read the data. Now I want to show the first two lines. If we don't specify any parameter, by default it will show the first two lines or 5 lines. So now I want to show only 2 lines. So duration, protocol, source IP, etc. are available. So first I will check whether is there any null value. So no, there is no value which is null. So now after that we can see the data types. So here you can see there are 1, 2, 3, 4 are the categorical type of data is there, like a protocol, source IP, destination IP, and object. So even if you display, you can see TCP IP, source IP is again in the form of categorical. So now we need to convert this into numerical value. So using the encoding technique. So now you can see TCP is represented by 1, UDP is represented by 0, ICMP is represented by 2. And again each unique IP they got the number like this. Again, if I show you first 10 lines or more, so here, now you can see here. So these are the protocol, they got the number. And earlier for the label, it was attack or normal, now it become 1 and 0. So now it become 1 and 0. So again, if you see the data types, so earlier we had 1, 2, 3, 4 kind of objects are put there. Now it is into the integer format. Yes, please. Any doubt? Any participant has any doubt? Okay. Now, then you can check. Now, what you need to do? You have to segregate the data into features and the label X and Y. So here we are going to drop the label and accept label. All the features will come here, like from the Excel this Excel file. We will be able to see all the data will be in X level and the label will be in the Y. So that is the target, and we can then after that we can split here. So this is the split function, train test split. So you will get the X train, X test, Y train, Y test. So your training data consists of training feature, training label, test feature, and test label. And then you can reshape data to ensure it is a two-dimensional. So you can see here again. So this is the now X train data, and this is your X test data, test data. This is a test data, and now this is a train data, train labels, and this is the test labels. So final prediction we have to compare with the test labels to get the confusion matrix. So if you see these are the values. So these are the values, and now we can see what type of data type is there. It's a NumPy data, and we can see again it's in the form the array form. Now we see the if you see the 2000 samples were there. Now we have reshaped to the column. So we have now 12,800 samples are there. The length of the train reshaped. Or using this also we can check either length function or using the size function. Or if we see the shape, now you have one column. So first is for the row, second for the column. Then again we can check here. So any value you want to convert into row and column, so you can give the any arbitrary number like here and the column, because we don't know how many rows are there, so we have given here -1. Then finally we have reshaped this value and we got this value. Now after this now your training start from here. So it is very easy now if you want to implement random forest. So from sklearn library there is a officially you can explore it, scikit-learn.org, or even if you can explore their GitHub or github.com/scikit-learn. Each and every information and code is available here, scikit-learn. So we are using the sklearn library and we are using the random forest. So after that, we are initializing in a variable like model. We are giving the an estimated random state and model.fit. In fit, we are passing the training data and training label, and we are getting the prediction. And directly we are specifying here the accuracy score And in accuracy score, we are passing the test level and the prediction level. So now we'll see here. So now after this, we got only 48% accuracy. So that means we need to increase the data size or we have to do the fine tuning. So now we can try some other model. So support vector classifier or SVM classifier. So again from sklearn.svm import SVC, we can see here what type model is a support vector classifier, and we can fit the train feature and train level, and we get the predictions here. So model.predict, now we are passing the test features, we are getting the predictions. So these are the predictions are there. Again, from sklearn.import classification report, accuracy score, confusion matrix, we can print the confusion matrix. So now easily we can find the accuracy, precision, recall, and the F1 score. So then we can predict here. So again, you can see accuracy is now from 48 to 51% we have reached. And remaining, these are the accuracy, precision, recall, F1 score. Now, next is what the K nearest neighbor. So in K nearest neighbor, we want to predict using the KNN, but the value of K is very important. So for that, we can have multiple values of the K, and we can see the training accuracy, and we can see the test accuracy. So here we can see the training accuracy is 100%, 73%, 74%, 67%, again 67, 65, etc. And training accuracy is 50, 50, then 50 again, around this. So when training accuracy is very high and test accuracy is low, then it is a problem of overfitting. And when training accuracy is also low, test accuracy is also low, then it is a problem of underfitting. So we have to avoid this. So what we can do, we can visualize and we can see the where we are getting the both things at the optimum level. So here you can see the accuracy is very high, but testing accuracy is very low. So here you can see that training accuracy is very high, but testing accuracy is very low. And again at this point, okay, to some extent, but at this point you can see the training accuracy and testing accuracy is more as compared to the other point. So this is the problem of the overfitting, and remaining points are the problem of the underfitting. So here we can select now 9 value according to this point. So training accuracy is also more and testing accuracy is also more. So now in the we can specify here the neighbor value as 9, and we can run it. Then we got 63 and 53% accuracy. So you can see from 48 to 51, 51 to 53 we reached. Then we can try some other model like logistic regression. So this is a under linear model logistic regression. So we are just only these two lines we need to change. Whatever the algorithm we are going to use, remaining things are same. So dot fit for training feature, train level, and we can predict the directly score. So now we can get the 52 and 50%. So like next we will do for the decision tree. So just two lines we need to change. We are calling from the sklearn decision tree classifier, and remaining parameters are same. So we are getting here the training accuracy is 100%, testing accuracy is 47 directly. So that means it is learning a lot of noise, and there is directly the problem of overfitting. So we can now try the random forest. So random forest is always better than the decision tree. Now we can try, and we got again 100% and 50% accuracy. Then we can try for the gradient boosting. So again, you can see here from the sk dot, it's an unassembled technique. So we are importing gradient boosting classifier, and we are training and getting the accuracy. So now here we got around 79 and 50% accuracy. So now same with the SVM, we can do the fine tuning also. Again 51 and 51, 50%. Then we can go for the neural network. So we can import the neural network classifier and we can fit. Again we reach to 52. Now we can try for the XD boost. So you can see now it is very easy. Once we have the data, we can implement the XD boost classifier. Then we can apply the naive Bayes classifier. So again in naive Bayes we got 55 and 51. So now we can try for the ADA boost. So now we can try for the ADA boost. So from sklearn.ensemble we can import the ADA boost classifier. So again we got this much accuracy. Now we can do the voting classifier. So let's say random forest, gradient boosting and ADA boosting are giving good result. So we can specify into 3 parameters variables, and then we can call the voting classifier. And estimators we are passing a random forest, gradient boosting and ADA boosting, and simple one parameter we are specifying here. Voting is equal to hard. And in case of soft, just we have to change this parameter. So here you can notice this. So how to implement soft? So just here in the voting we will write here soft. That's all. Remaining code will be same. So now we can apply this and we can check it also. We can visualize it also. So we can see now we are doing we have the random forest, we have the gradient boosting, and then we have the ADA boosting, and we can now get the result. So now we will get the 4 results here, one for the random forest, one for the gradient boosting classifier, one for the ADA boost, and one for the voting. So you can see we reached up to 51, 50, 51, and again the accuracy is 51 in ensemble. Same we can see here in the soft computing. Just we have changed only one parameter, that voting is equal to soft. And then we can see the accuracy. So again, it is showing random forest 50, 50, 51, and again it will be around 50% because we have very less amount of data. So again, this one. So now I will repeat what I have done here before going to the second section. So here we got the small amount of data for demonstration purpose that was from the distributed denial of services, and there it was predicted here whether it is a type of attack or it is a type of normal. Now here we have import the warnings to suppress the warning sometime because it may tell you that this version is going to update, this version is going to obsolete, so all kind of these things. So in the data set we have the duration, protocol, source IP, destination IP, source port. So it is a combination of numerical data and categorical data. So we have, from google.colab we have uploaded the file. Then after uploading the file, we have seen the data using the pandas library and sklearn library and numpy, only 3 libraries, and matplotlib, only 4 libraries has been used. So using these 4 libraries, using pandas, we have read the this Excel file in the data frame format. Then we have checked whether there is any null value. There is no null value. Then we have seen the data types. So 4 of the protocol, source IP, destination IP, and label, they were in the object as a categorical. So using the label encoding, we have converted that into the uh, numerical. So now you can see each and every, including label, source IP, destination IP, and protocol, now are in the numerical format. Then again, we can verify using the print dot data types. We got the integer. Then we have break down the data into features and the target, that is X and Y. These X and Y we have passed into the training test split along with the other options. So the other options was 20% we have specified in the test size, automatically 80% goes to the training test and random state. Then we have reshaped to ensure it is a two-dimensional, and then we have after that we have view it, and then we have given to various machine learning algorithms. So what are the various machine learning algorithms we have used? So we have used here uh, random forest, then support vector machine, then we have seen about the KNN. After KNN, we have seen about the logistic regression, decision tree, random forest, gradient boosting, support vector machine, neural networks, XGBoost, ADA boost, voting classifier, and then soft and hard voting we have done. Now in next part, the link is given also there. From this link, you can download the dataset or also provided in the Google Classroom. So all of you can download the dataset and the source code. And now we'll see about this dataset was provided, which consists of wide variety of intrusions. This is simulated in a military network environment, and it created an environment to acquire raw TCP/IP dump data that from a network by simulating a typical US Air Force LAN, and the LAN was focused like a real environment, and it was blasted with multiple attacks. A connection in that is a sequence of TCP packets starting and ending at some time. That duration has been noted down, and which data flow to and from a source IP to the target IP under a well-defined protocol. And each connection is labeled as either normal or attack. And each connection record consists of 100 bytes. For each TCP connection, 41 quantitative and qualitative features are obtained. So to identify. So now I will show you the presentation, then we'll read it. Meanwhile, let me show you the this dataset. So again, this dataset is in section 2. There are two files are available. If you see in section 2, so we have the train data and test dataset. So if I open this file, so you can see the duration protocol, what type of service is there, whether it's FTP, whether it's HTTP, private. So you can see now it's a very complex data. Then we have the source byte, we have the destination byte, we have the number of failed login. They have tried somewhere here. Number of failed logins logged in, number of compromised root shell, number of files. So many attributes are there. Very in detail you can see. So many features are there. And in the last, it is defined as normal or anomaly. So here you can explore this data. The data set is available, and it's a huge amount of data is there. Approximately, if you see, it consists of around 25,000 packets are there, 25,000 tuples are there. So similarly, you can see about the test data. So here, now we have separated this. So in test data, again, it consists of around, again, 22,000 tuples are there. So you can see this data set is available. So you can also capture real-time data set using these tools. So there you can you can save into the CSV format. There is option, like in Wireshark also there is option. And then you can see here, this is the test data and there is no label. So we need to do now the prediction. What type of, whether it's how much, how many attacks are there and how many are normal. So now we need to read these two files. So we'll select here and we can go to that particular folder, section 2, and we can select all or control A. And we can open and upload. And after uploading, we can read the train data and test data. Now it's uploading. You can see here. Now it is uploaded. It's in the progress. So now here we are defining our own architecture, deep neural network architecture. So what is the difference between deep neural network architecture and like convolution neural network? So dense layer in deep neural networks, or there we use a dense layer. Now what is dense layer? It is a layer which is a fully connected layer. So it is a type of deep neural network or neural network layer where every neuron is connected to every neuron in the previous and the next layer or subsequent layer. So if I show you diagrammatically here for your understanding. So here, if I show you here, so here, let's say you have 2 neurons, and here you have 3 neurons, and again let's say you have 3 neurons in middle layer, and finally you have one layer which will predict whether it's malicious or normal. So now you have the connection with all the neurons. Again, this will have the connection with all the neurons. Again, this will have the connection with all the neurons. Again, this will have the connection with all the neurons. Again, now like this. So because of this reason, so it is called dense layer. So we are now going to use a dense layer. So it is a fully connected layer. So it is again a type of neural network where every neuron is connected to every neuron in the previous as well as in the subsequent layer. So what is the purpose of this? It learns the high level abstract representation by combining the information from all neurons in the previous layer. So here you can think of it like also like a voting system where every neuron, each neuron is important and they participate in the decision making. Whereas in convolutional layer, we apply a convolutional operation to the input. And that is normally in case of images where have, so in image, let's say we have an image of size, let's say 500 by 200. So how many pixels will be there? So it will be 1, 2, 3, 4. So it is a 1 lakh. 1 lakh pixels are there. So because of now each pixel is represented as a neuron. Each pixel is a one neuron. So we required 1 lakh neurons. So if we go for dense network, so system will fail. So input features will be your neuron. So it is very difficult to implement the uh, image data or video data using the deep neural networks. So there we use the concept of convolutional layer. So directly we give the images as the input and we extract the spatial feature like edge, texture, patterns, etc. Or we capture the hierarchical information in the data, pixels in the image. So there is the concept of kernel, which slide over the input image and perform the element-wise multiplication. So input into kernel plus bias, and we got the initial layer, deep layer, and now today we are not talking about the CNN, but that is the major difference between deep neural network and CNN. So there is a concept of filters, padding, stride, etc. So in dense layer, we have fully connected to all the input. Connections are what type of connections are there? Fully connected to all the inputs. And in convolutional, connected only to the local region. So it works with the one-dimensional data, and whereas convolution work with the structured data like images, or maybe two-dimensional or three-dimensional. So when we required reasoning or classification, we can use the dense layer, and where we require feature extraction and pattern detection, we can use a convolutional layer. So learning parameters are few in convolutional, and more parameters are as all the neurons are connected. So learning parameters are more in dense layer. So I hope now you got some idea. So now it's uploading. Okay, we will run it again because there was disconnection. So now I'm going to try again. So we'll select the file under section 2. We have the train and test data. So we'll upload there. So again, it's uploading. By the time I will explain. Now in section 2, what we are going to do. So we are going to perform the data exploration. First, we will do some kind of exploration. So we will import the libraries for data handling like pandas, numpy, etc. We can upload the testing. We can inspect the data just like in previous case, and we can check for missing values or duplicate. Then we will do the exploratory data analysis. We can analyze the target variable distribution. We can explore the categorical feature using the count plot. We can compound the correlation matrix for numerical features. And where we have the high correlated, we can drop that, and redundant or high correlated features. Then we do the feature engineering, map the target variable to numerical label. So there we can use the one hot encoding categorical variable, and we can drop the less useful features. So now it is being uploaded. Then we do the model development. So there in this demo, I will so you can use all the previous one machine learning algorithms like we have done SVM, support vector machine, KNN, or this simple neural network. You can do XGBoost, AdaBoost, voting classifier. So just I'm going to show you only one logistic regression. So first we'll scale out using the min-max scaler. So all the features we are going to make in the range of 0 and 1. Then we again split the data into training and testing, train the logistic regression model, and evaluate the performance. Then we are going to deploy our own deep neural network. So here we can read this, and we can set, we want to display more rows and column. So display maximum rows. So what is the meaning of? Otherwise, if you don't specify, you will not be able to see all, because it's a long many columns are there, many rows are there. So none means you are setting it to none remove any column limit. So it will allow all the columns in the data frame to display regardless of their number. So you can see in the data frame, so all the columns it will show. You can see here all the columns it is going to show in this way. Now you can see all the columns it is going to show. So similarly, we can set for the test data. We can see the what type of data is there. So it is a pandas, and these are the columns are there. How many columns are there? 41 columns are there. So out of 41, 23 are in the form of integer 64, 4 are in the form of object, and 15 are in the form of float 64. So here also you can see protocol type, service, flag, this is the object, and again your class is also the object. Then you can see the information here. So you have you can see the training data information and test data information. In test data information, you have the 40 features. You don't have the target value because that is our job to predict. Then you can check, is there any null value? So we don't have any null value here. So similarly, we can check for the test data frame. There is again no null value. Then we can train the We can check, is there any duplicated value? No, there is no duplicate value. We can see the statistical information using the describe. So these are all the parts of the data frame. Those who are new for the Python, yes, please. Any doubt? So, and those who are new for Python, they can explore these W3 schools. So I am pasting this link here also, as well as in the our chat box. So you can see here, you can explore this from the W3 school. I pasted the link in the chat box. Then you can see the statistical information. Now these are all the part of the pandas library. So you can see the count of non-missing, mean value, standard deviation, minimum value, percentile, first quartile, median, third quartile, and also if you are aware of the outlier, using this information you can go for the predict the outlier also. Now we are going to see the categorical features. So what are the categorical features are there? If you remember, it was showing 4. So protocol type, service, flag, and class. And the data type is object. You can visualize the target variable. So when you visualize the target variable, so you can see out of these 20,000, around 13,000 are normal, and uh, around 11,000 or around 10,000 are anomaly. So it is a balanced class. It is not imbalanced. So now you can see you can count also. Normal 13,000 are there, and anomaly are 11,000. So almost you can do the different type of plots as per your requirement. So this is a count plot we can apply. So we can see in respect with the TCP, with respect to UDP, and with respect to ICMP, normal and anomaly. Now we can also plot the figure size. So we can plot it also. We can save it also from publication point of view. We can see the count plot. So these are about the EDA. Now, after that, after doing the EDA and everything, now we start with the implementation. So in implementation, we required numerical features. What are the numerical features are there? What are the columns are there? So these are the columns, numerical feature dot columns. So these are the columns are there. So now we can see the correlation. So just you can see, and we can sort with the help of the sort values. We can see the correlation in ascending order. So now correlation, and this is not a number. We can visualize it also. So you can see the correlation is in the negative as well as in the positive way. So we can plot the heat map also. The dense color or high color emphasizes it is a more correlated, and less color, like in a traffic, where is a high traffic, so more or high color or dark color shows a high traffic, or less color shows a less traffic. Similarly here, now we have the feature, we can see the correlation. We can using heat map or using the correlation matrix. Why this correlation is required? So now you can see the number of root with the number of compromised server source error rate. So we can drop those value, strong correlation. We can make the separate list, and so we can print. These are the columns which are more correlated, and now we can see here this is a shape, and we can drop the strong correlation list. Now after that, we can see we can drop the services, and then we can see the shape. So now how many we have dropped here? If you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 features we have dropped, and now we got this. So this is a test that shape. This is for the training. So here now again let me explain here. So what we are doing here, we are uh, after deploying the logistic regression, we are having the deep neural networks we are now going to define. So in the deep neural network, we have the neurons we are defining as input layer has 64 neurons, and we are using the activation function ReLU. And in the hidden layer, we have the 32 neurons with the one dropout. Then output layer has a one neuron, as it's a, so it will show as 0 or 1. So one neuron is sufficient. Then we are using the early stopping to prevent the overfitting. Now, what is this early stopping? This is a very crucial and important point while the implementation. And we are also using the binary cross entropy. So what is early stopping? Early stopping is a technique used during a model training to prevent the overfitting. Now, how it works and what is the meaning of this? So let's say when we train the model. So during training, it will check whether on certain number of epochs, that is also known as the number of patients. I will show you in the code. So after, let's say you have given the patients number as 5. So it will see the epoch 1, 2, 3, 4, 5. If there is no further improvement, it will stop the training process. So for this demonstration, I have taken the patient's value as 3. So it will check for 3 epochs. If there is no further improvement in the training, so or in the uh, during training, it will stop the training process. So through this, we can control the overfitting and as well as the processing time. So why we use early stopping? So it prevent the overfitting, stop the training before the model start overfitting to the training data. It will save the time and it will select the best model. What is the best epoch is there? So what is the meaning of binary cross entropy? So it is used loss function for binary classification. It calculates the difference between the predicted probabilities and the actual level for two classes. Then with deployment using the optimizer, there are various optimizers are there. One of the optimizer which is used here is Adam. So Adam, it combines the benefits of both momentum and RMS prop. It keep track of the past gradients to smooth out the updates and scale the learning rate. Then we use a adaptive learning rate for each parameter. So we specify the parameter learning rate and the exponential decay rate. So why we combine these techniques, early stopping by binary cross entropy and Adam optimizer. So early stopping ensure the model does not overtrain. So I will show you now practically, you will get better clarity. And binary cross entropy is well suited for evaluating the binary classification problem. So now in this architecture, what we have done, input layer. So we take the accept the input feature from the dataset. So now if you see the again the Excel file, so if you see here again the Excel file, so how many input features are there? Input features are the columns 1, 2, 3, 4, 5, 6, 7, 8, and so on. So all these except the label, so many features are there. So here in the presentation, you can see accept the input features from the dataset. And the number of neurons will be equal to the number of features, that is the columns in the dataset. So that's why if you are using some image and where you have the 500 into 200 pixel value, so you will have 500 into 200 will become 2, 2 to 4, 5, 6, 1 lakh. So 1 lakh neurons will be there in case of, that's why convolution neural network techniques is better as compared to the dense network. But in our case, only 40, 41, 35 or 40 features are there. So each column will become the number of inputs. And in input, we don't require any activation function. Then we have the hidden layers. So in the first hidden layer, we have used the dense layer. So I hope now it is clear what is dense layer. So all the neurons are connected with all the 64 layers. So that means if I have here 3 layers, or let's say 5 input layers, 1, 2, 3, 4, 5. If I have 5 features, 1, 2, 3, 4, 5, and here I have 64 neurons, 64 neurons. So all are connected to all the neurons. So it is a dense. So a lot of computation is required. Again, it is connected with all the neurons. So This is the meaning of the dense layer. So even in convolutional neural networks or those who implemented deep learning, in the last we have to do the connectivity with all the these things. So you can see now it is connected with the all the neurons. So that introduces the non-linearity to the model. So now because there are so many neurons, so around 50 to 60% or 40 to 50 we can drop out. We can deactivate during training to prevent the overfitting. And then we have the second hidden layer. In the first hidden layer, how many layers are there? 64 neurons. After that, we have implemented the 32 neurons, again with the attribution function value. Then we have again done the dropout. Then we have the output layer with one neuron, and we have used the sigmoid function because we want to get the, it will give the probability in between 0 to 1, and we can give threshold value. If threshold is 60%, then above 60 will be 1, below 60% will be 0. Then we do the model compilation, and that is suitable for binary classification, and we have used the matrices accuracy. Then we have done the early stopping. It will stop training if the validation loss does not improve for 3 epochs. So we have given here 50 epochs. That so when 1 epoch means we are passing the entire data set from the model, that is a 1 epoch. And batch size 32 means number of sample processed at a time. So what is the meaning of this? Suppose we have 100 students and they are visiting some lab. So in the lab, only 20% can be accommodated at one time. So how many batches will be there? Total 100 divided by 20, it will be 5. So each well size will be of 20, 20, 20, 20, and 20. Suppose they want to visit 3 labs, and each lab has a capacity of 20. Maximum 20 students can come. So now we cannot send the entire sample. So what we can do, we make the 5 batches, each of size 20, 20, 20. So when the entire class, when they pass through the lab 1, that is known as 1 epoch. When the entire 100, when they visited from the lab 1, that is 1 epoch. Then they will go for lab 2. So again, when they pass all the 100 students they visited to the lab 2, that is another epoch, so epoch number 2. Then they will visit to lab number 3. So that is again in the code I have written the meaning of epoch and batch size. So normally we keep batch size 32, 16, but we should not give more because of the memory constraints. So now how many epochs we have done here? 3 epochs. So what is the meaning of epoch? When the entire data set pass through the model, that is a epoch. So we have set here 50 epochs and batch size of 32. So let's say we have a sample of 320. So 320 divided by 32. So that will be 10. So 10 iterations will be there. In one epoch, how many iterations will be there? 10 iterations of each sample size 32. So again, in the code, you will see this. Then we can do the model comparison with any of the machine learning algorithm and ANN. So for this uh, example, I have used only logistic regression, ANN, and these are the matrices. Then we can visualize, we can test on the unseen data, and we can also save for future use. So now we'll learn these things, how to save. So in the code, so now after doing the feature engineering, we got the training data here. We can see the columns. We can now converting into categorical to numerical value. So we can use a get dummies. So here now we can see the what is the shape of this data set. We can similarly we can do for the test data set. And now this is a model deployment. So here we have the logistic regression. So there we are doing the We are calling this model, and you can call the previous models also. You can try previous model. Then we are doing the min max scaler, and after performing the min max scaler, we are getting the training data and the training labels, and we are splitting the uh, or entire features, we can say, and the entire labels that we are passing into the train test split method, and then we are fitting to the transform to reduce the computation, and same we are doing with the test data. And now we fit the model with train data and training this one. We got the predictions here, and we can see the classification report, same like in the previous case we have done. Now here we can see we got around 96% accuracy. So now we can specify our own deep neural networks, also known as, also we can say as deep neural networks. Or deep neural network. So from TensorFlow, we are calling some layers like sequential, dense, dropout, early stopping. Now this is a model which we have shown in the presentation. So we have the first layer with the, we have specified here dense 64, activation is ReLU, input shape is the X-train shape. Then we have done the dropout. Then we have done the 32 for the dense layer dropout. And then we are doing the binary classification, and optimizer we have used as Adam. And here we are mentioning the early stopping criteria. So how much patients we have defined here? 3. Now you can see here, we have defined this variable early stop, and during the fit, we are specifying this X train, Y train, validation data, epochs 50, and we are calling callbacks is equal to early stop. Now you can notice here, you see here carefully. Now in the epoch, so you can see here the validation loss is 0.113, then it is reducing, then again it is reducing, again it is reducing, again it is reducing to 0.73, again it is reducing, and you can see the validation loss. So it is going in a good way, 0.0590, 0.560, 0.527, 521, 536. Now after 521 it is increased, but again it is decreasing in the next one, 489, 471. So we have given the continuity for the 3 epochs. So again it is running here, 420, 441, and now you can see here. So what is the meaning of this early stopping? You can see here 0.489, 460. Again, instead of losing, now it is increased here. Now in the next epoch it decreased, so there is a significance change, again decreased. Now from 420, now 441, so it is now increased here. Now as compared to this 4.0 in this epoch, it is increased here. Again in this, so again it is increased. So in next 3 there is no further improvement. So you can select 3 or 5 patients value. So there is no, so what will happen? It will stop here. So final output you will get here. The validation loss is 0.042. So this is the meaning. So in this way you have saved the valuable time of computational resources, and you have get the optimized value. So I hope now early stop. And what is now epochs? So epoch refer to one complete pass of the entire training data set. So if you are setting 50, that means the model will train your entire data set 50 times. So it will increasing the number of epochs can lead to better training, but it overfitting or underfitting could be happen. Then what is the batch size? So how many samples we are sending at one time? So that is a batch size. Instead of feeding the entire data set into memory, which could be computationally expensive, we have to divide the data set into smaller data set. So let's say if we have the data set of 10,000 samples and batch size is 32. So the data set is split into how many batches? 10,000 divided by 32, 313 batches. And each batch is used to compute the gradients and update the model weight. So now you got some loss value, you can plot it and you can publish in your journals like this, and you can do the predictions here, and you can print the classification report. So now you can see in case of other, the accuracy was 96, now we got the 98%. So now I hope you understood what is precision, what is accuracy. Then you can compare the model and you can display the models also. So you can see in terms of precision, in terms of precision of class true, negative, true, negative, true, negative, and true, negative. Recall, F1 score, and accuracy. And then you can test the model on new data. So how you can test the new data? You will read the test data, and you can see here. So that is in the X test, and then we fit the model. Again, now this is the model we have defined, and again you can compile it, and you can fit the with how many epochs? 50. Batch size is 32. Validation is 0. Split is 80%, and criteria same, callback. So where we have defined this callback? So we have defined this callback in the here previous value. They had with the patience value as a 3. So now it's running here. So now you can see the loss was 0.320. Here it was 0.9593. Then it is increased in the next epoch, and it is increased. So there is no further changes in the 3 epochs. So it got the early stops. So we got the validation accuracy at the loss of 0.9593. Then we can predict it, and we can predict the test predictions. Now how to save the model? So now here you have the prediction data frame, and this is the predictions. You can save prediction data frame to CSV. You can save in this file, and you can see these are the predictions, and you can see the model summary, whether you are working with the TensorFlow or Keras. And if you see here, keras.io, and if you click on the examples, you can implement image classification, image segmentation, object detection, 3D, OCR, image enhancement, all these things. So if you are working on knowledge distillation, if you click on any topic, you will get the entire code also. So you will get the entire code, and you can see the concept of these epochs and the accuracy you are getting. So now I will paste this link also. All of you can try. Okay. I will take another 1 minute, and then I will come to the questions. So we reached up to this point. So we have seen, as I mentioned in the presentation, so 64 we have specified as a dense layer, then dropout, then we have done 32, then dense with the 1. So total parameters are 14,789. Trainable parameters are these many, and model.save. So simple in TensorFlow, there is a utility .save, and you can give my intuition.introduction.hsave, and you can save in this way. Now I will see the questions. Okay, there is a question how to envision the use of blockchain technology in cybersecurity analytics. What impact will 5G adoption have on network security and analytics? So I think I left with the 2-3 minutes, but I hope you can see these papers with code, and under here you will get the data sets. 11,000 data sets are there, and you can see the methods. So you have attention based method, attention mechanism method, activation functions, computer vision, you can NLP. So whatever your area of interest, like 5G or blockchain, you can explore these. So, or if you are, or in the, if you have joined the Google Classroom, you just post your query and we'll try to supply you the answer. So I am pasting this link also. Please explore this one too. Any question related to this, specifically to this topic? Okay, there is a question, what is epoch and what is iteration? So now here, I hope you will be able to see uh, this slide. So let's say there are 1000 students and they want to visit 3 labs, and capacity of each lab is 20. So now what we have need to do, we have to make the batch of, so what will our batch size? Batch size will be 20. And now how many iterations will be there? Iterations will be 1000 divided by 20 for one lab. So it will be 50. So 50 iterations will be there. First batch is coming, second batch is then going, then coming, then third batch is going, and so on. So total number of batch size is 50. So total number of batches will be, total number of batches, total number of batches will be 50. I hope you got the idea. So it depends on the total number of batches. So you will have the 50 iterations. This is a 50 iterations. So when entire students visit to, let's say their name is lab 1, lab 2, lab 3. When entire student visit to one lab, that is known as one epoch. That is known as one epoch. So that means when entire data set passes through the model, that is one epoch. So now in our case, we have defined 50 epochs. We want that entire data set should pass through the model with 50 epochs. And in addition to that, we have specified there one value, patience, or also known as early stopping. If we don't specify this, what will happen? It will take a lot of time. Now in early stopping, I have given the patience value as, let's say I have given 3, let's say I have given 5. So in each epoch, or in each epoch, now how many epochs are there? 50 epochs are there. So now in each epoch, when entire data set passes through that, we are getting the validation loss, and we have to minimize it. Validation loss. So let's say validation loss is vary from different places. So let's say for your understanding, let's say patience value is 3. So now let's say we got the 0.401. After this, we are getting 0.405. After this, we are getting 0.501. After this, we are getting 0.601. Let's say patience value is 5. And after that, we are getting 0.409. After that, we are getting 0.4.2. So as compared to this epoch, there is no improvement. So it will stop here. So finally, we will get this value. So please feel free. Have you got this concept? So there is another question. How effective are modern security information and event management systems in handling the growing volume of security data? So now because of this, you might have noticed that AI-based techniques are coming because huge amount of data is there. I don't have time, so you note down this website, internetlivestats.com. You will see, you will be surprised to see 2 trillion or you can decide 2 billion emails sent today. This in one day. 50 million watched YouTube. All stats you will see. Huge amount of data. 1 million uh, videos uploaded today. And you will also see two more parameters. How much electricity consumed today. So it is around 20 to 30 million watts. And how much carbon emitted today? So again around 30 plus ton carbon. So all these you will see there in this. So it become, and there is another issue of the dark web or darknet. So in today's context, you can see many tools are coming, security information and event management systems are coming, and many they are going thrust in the AI or ML based. So what differentiates a zero trust security model from traditional network security? Normally, zero attacks are those attacks which are unknown. So because in the consequent classes, you will see like the experts like Dr. Gaurav Kumar, Vipin Gupta, and many more. They have the hands-on experience on these kind of questions. But still, if you have joined to the Google Classroom, kindly post these questions. So organizers, I think now there is a next session. What is the difference between big data analytics and predictive analytics in cyber security? Okay. When like if you see this is a big data which we specify with the various attributes. When we have the in terms of volume, we have around 7 V's are there. Some books mention 5-7 V's are there. In terms of big data volume, it is increasing exponential. Then velocity means now you have if you see the py.org or sf.net, or if you see the our
Thank you, Amit sir. Sir, am I audible?
Yeah, yes, sir. Yes, sir. Yes, sir.
Okay. Thank you, Amit sir. It was wonderful talk. Your expertise and depth of the knowledge you shared have truly eliminated the nuisance of the cyber analytics for all of us. You have not only broadened our understanding but also inspired us to think critically about the evolving challenges and opportunities in the